Okay, this is the fourth and final video for motion under variable force and acceleration. Looking at this example, the acceleration of a particle travelling in a straight line is given by dv dt is v plus 1, where v is the velocity at any time t. At t equals 0, the body is at rest, so that means our initial velocity is 0. Determine as a function of time the velocity. So our acceleration, which is equal to dv dt, is equal to v plus 1. So that means I need, because our v is on the right and I've got t on the bottom, that I need to invert. So dt dv is going to be 1 over v plus 1. No idea why that control sign is on. So to get t, I need to integrate. So t is going to be the integral of 1 over v plus 1 dv, which is going to be our natural log of v plus 1 plus c. And our initial conditions, t is 0, v is 0. So that means 0 equals ln of 1 plus c. So c is equal to 0. So that means t is equal to ln of v plus 1. We need to make v the subject. So if we change into an exponential, well, it might help if I write it as log e of v plus 1. So our base of an exponential is e to the power of t is going to be v plus 1. So our v is equal to e to the t minus 1. The other way you could do that is just take the exponent of both sides. Next one, we need our acceleration. Well, if v is equal to e to the t minus 1, then our acceleration is dv dt, which is e to the t. Last one, position. Well, v is equal to dx dt, which is e to the t minus 1. So our x has to be the integral of e to the t minus 1. So that's going to be e to the t minus t plus c. And it starts at the origin. So that means when t is 0, x is 0. So we have 0 equals e to the 0 minus 0 plus c. 0 equals 1 plus c, so c is negative 1. So therefore x is e to the t minus 1. Last example with this video, the acceleration of an object in a straight line is given by, where x is greater than or equal to 0, x is a position at any time t, velocity is 1 when x is 0. Explain why the velocity is always positive. So if we start off with our a to the x is equal to e to the x plus 1, and x is always greater than or equal to 0. So we know that e to the x is always greater than 0. Okay, it's always positive. So therefore e to the x plus 1 is always going to be greater than 0 for all x. So the velocity v is always increasing. As x increases. At t equals 0, v is equal to 1. So as x increases, v is greater than 1. So therefore, velocity is always positive. You could probably explain it with graphs as well. Part B, determine the velocity v of x in terms of the position x. So a of x is equal to e to the x plus 1. So v dv dx equals e to the x plus 1. v dv has to equal e to the x plus 1 dx. Integrate both sides. So that means we have v squared over 2 plus c equals e to the x plus x. X is 0, v was equal to 1. So a half plus c has to equal e to the 0 plus 0. So a half plus c equals 1. So c has to be a half. So therefore we've got v squared over 2 plus a half equals e to the x plus x. Rearranging everything, we've got v squared over 2 equals e to the x plus x minus a half times everything by 2, 2e to the x plus 2x minus 1, and then do the square root. Now it has to be positive. V is greater than 1, so we only need the positive square root. Okay, now again I've used that same formula that a is v dv dx. The textbook doesn't do this, so I've used a equals v dv dx. They've introduced another formula. I just think it's easier to just use the one. Questions following these examples: MathQuest exercise 12C, page 571, question 8 to 10.